Welcome everyone to another Explainer. I'm so hyped you're here today because we are taking on an absolutely massive topic for anyone studying Cambridge physics, specifically targeting syllabus 0625, but honestly this is just as crucial if you're taking 0651, 0652, 5054, or even setting your foundations for 9702. Today, we're going to act like geneticists, but instead of biology and gene splicing, we are going to engineer the perfect DNA of a physics exam answer. We're looking specifically at a concept that literally trips up thousands of students every single year: forces and balance. Our goal today isn't just to memorize a bunch of boring facts, it is to build a rigorous, application-based understanding that will make you practically bulletproof on your exams. To set the stage, I want you to imagine two typical physics students. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads every answer with raw physics facts, just throwing every equation at the page, but with absolutely zero analysis. Sam, on the other hand, rushes. Sam completely misses the command word requirements and just writes whatever comes to mind first. Today, we're going to look at their flawed answers, see exactly where the red pen marks come from, and transform that into a flawless strategy. We're talking evidence plus analysis equals an A-star.
Okay, let's dive into this. Here is our roadmap for today's masterclass. First, the forces challenge hook. Second, everyday language to physics. Third, common exam answer weaknesses. Fourth, the four-step answer formula. And finally, number 5, 4 essential memory prompts. It's a packed agenda, so let's get right to it.
Section 1, the forces challenge hook. Look, we are kicking things off with what our source material calls application-first teaching. Now, a truly strong physics lesson shouldn't just hand you a list of facts and equations to memorize. If you're just staring at a board full of symbols like F equals ma or W equals mg, the physics feels completely detached from reality. It's like learning a language by only reading a dictionary. It doesn't work. Instead, a great lesson makes the concept feel entirely necessary before introducing any of the heavy math. Picture Alex and Sam sitting in their exam hall. They get a question about a falling skydiver reaching terminal velocity. Alex writes down every force equation known to humanity but doesn't actually explain the balance. Sam just writes, the forces cancel out, and moves on. Both of them lose massive marks. Why? Because they didn't grasp the real-world application first. They didn't see the physical necessity of the forces acting on that skydiver. So I want to pose this challenge directly to you right now. What physical effect, measurement, or prediction depends on understanding forces and balance? Think about why we even care about this stuff. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to our challenge. By answering this question first, by recognizing the physical necessity in the real world, you become far less dependent on memorized wording. When Cambridge throws an unfamiliar, incredibly tricky exam question at you, you won't panic. You won't freeze up like Sam. You won't word vomit like Alex, because you understand the actual physical reality, not just the textbook definition. You see a bridge, you understand the tension and compression keeping it static. You see a floating boat, you understand buoyancy and weight. That is the secret sauce. The formal language comes second. See the physical necessity first. I cannot stress this enough. In the Cambridge 0625 syllabus, the topic of forces and balance is not just decorative. It's not just some standalone chapter you have to slog through. It is actually a micro gateway into a much bigger, much more beautiful scientific pattern. If you grasp how forces balance in a simple physical system, you've unlocked the fundamental logic that applies to literally everything from orbital mechanics to static structures. When we understand the necessity, the formal language, the big scary words, just becomes a tool to describe what we already inherently understand. It's a total game changer for your revision.
Section 2, everyday language to physics. Once you actually see the necessity of the physics in the real world, how do you translate that foundational understanding into the strict, precise vocabulary required for top exam marks? Let's take a look. Now, what's really interesting about this slide is how it illustrates the journey of learning, and frankly, it shows exactly where Alex goes wrong. On the left, we have everyday language, which often just relies on isolated facts. Alex might write, "The box is heavy and the table pushes up." Sure, it's true, but it's not physics. On the right, we have physics vocabulary, which is entirely built on cause and effect. Our source material highlights a brilliant method here. You must start concrete. Use your everyday language to describe what's happening. Then, and only when you completely understand the physical reality, do you introduce the symbolic relationship. You bridge the gap.
So instead of the box is heavy, we say the downward gravitational force or weight acting on the box. Instead of the table pushes up, we say is exactly counteracted by the normal contact force from the table, resulting in a zero resultant force. Do you see the difference? One is an observation, the other is an A-star analysis. There is a golden rule for your Cambridge exams, and it's right here. If the topic involves fields, forces, particles, insist on cause and effect rather than isolated facts. Listen, if you're looking at a force extension graph, don't just say the line goes up. Sam does that all the time, and Sam gets 0 marks for it. You need to stress what the slope, the area, the direction, or the shape means physically. You have to decode the command words. If the command word is describe, you state what happens. But if the command word is explain, which it so often is, you must provide the cause and effect. Cause and effect reasoning is the absolute core of high-level physics comprehension. Isolated facts will get you a passing grade, maybe, but relentless cause and effect reasoning, that will get you top marks, every single time. Section 3, Common Exam Answer Weaknesses. Understanding the physics is beautiful, but knowing exactly where students bleed marks on test day is the other half of the battle. Let's look through the examiner's lens and see where things fall apart.
Let's walk through these common pitfalls. Think of this as a Find the Flaw interactive workshop. First common weakness, writing the correct formula but failing to explain the variables. This is classic Alex. Alex writes W equals mg but fails to tell the examiner that W is the weight force acting downwards. A correct formula is entirely useless if you don't explain the physical reality those letters represent. Second weakness, quoting a process without linking it to a physical effect. You can say the object is in equilibrium all day long, but if you don't explicitly state that this means the upward forces equal the downward forces, so the object doesn't accelerate, you lose the mark. And third, giving an example but failing to show why it follows from the physics. This is where Sam usually messes up. Sam will say, like a car moving at a steady speed. Okay, great example, Sam, but why? Your examples must always tie back to the underlying cause and effect. You have to say, because the driving force equals the frictional force, resulting in no acceleration, you have to close the loop.
Section 4, the 4-step answer formula. Now that we know what not to do, I am going to reveal the fail-proof blueprint to perfectly structure any forces in balance answer. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never missed our weekly exam strategy sessions. All right, let's get into this blueprint. This is the structural DNA we talked about at the very beginning. So the crucial point is this sequence right here. Definition, relationship, explanation, and application. According to our source material, this 4-step sequence is the absolute safest, most effective method for writing physics exam answers. Now, if you've studied English or humanities, this might sound incredibly familiar. It's basically the famous Peel framework, point, evidence, explanation, link, but perfectly adapted for the Cambridge physics syllabus. Point becomes definition, evidence becomes your mathematical relationship or formula, explanation remains your physical explanation of cause and effect, and link becomes your real-world application. If you format your structured responses this way, you are directly answering the command words the examiners are grading you on. You are literally making it impossible for them to take marks away from you. Let's break those steps down a bit further and watch the transformation happen. Imagine Alex and Sam using this. First, they identify the key idea or phenomenon. That's the definition. They clearly state we are dealing with balanced forces. Second, they state the relationship involved. This is where your equation or rule comes in, like Newton's first law. Third, they explain the underlying physics using that clear cause and effect chain we just discussed. They write out why the forces cancel. And fourth, they connect it to a real observation, a lab experiment, or a practical device. By forcing themselves to follow this Peel-style blueprint, Alex stops word-vomiting random facts, and Sam stops rushing past the explanation. In IGCSE-style physics, the absolute best answers demonstrate both deep theoretical understanding and practical application. You simply can't have one without the other. And speaking of practical application, look at the sheer scope of where forces and balance matters. We're talking engineering, safety, transport, energy systems, medical technology, astronomy. You must always be able to name at least one real-life situation where the concept matters. Let's do a quick speed scan right now. Imagine a data table showing the tension in a crane's cable as it lifts a heavy load at a constant speed. What's the core trend? The core trend is that the upward tension must perfectly equal the downward weight. Why? Because the speed is constant. No acceleration means balanced forces. That's transport and engineering right there. If you can explain why the physics helps us predict or improve outcomes in one of these fields, like ensuring a crane doesn't snap its cable and cause a safety hazard, you have proven to the examiner that you truly understand the material. You're not just a robot reciting a textbook, you are a thinking scientist. Section 5. 4 essential memory prompts. We've built the understanding, we've learned the structure, and now we need a mental checklist. This is how you guarantee the topic is completely secure in your mind for short answer and structured questions alike. This brilliantly illustrates how to condense an entire Cambridge syllabus chapter into a rapid-fire mental check. Imagine you have 30 seconds left on the clock. Ask yourself these 4 things. 1. What is the core idea? 2. What changes physically? 3. What quantity or graph shows it? And 4. Where is it used? Let's apply it to a skydiver reaching terminal velocity. Core idea? Air resistance balances weight. What changes physically? Acceleration drops to 0, velocity becomes constant. What graph shows it? A velocity time graph flattening out into a horizontal line. Where is it used? Parachute design and safety. Boom. In 20 seconds, you just outlined a perfect A-star paragraph. If you can recite the answers aloud to these prompts without checking your notes, your knowledge has shifted from scattered, isolated facts into a fully connected, robust framework. You have mastered time management, and you are entirely ready for the exam. I'm going to leave you with a challenge. Look around the room you are in right now. Find a physical system. Maybe it's the chair you're sitting on, a book resting on a table, or a door hanging perfectly still on its hinges. Can you apply those 4 memory prompts to it? Can you define the relationship, explain the physics, and describe the application? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Remember, to master these papers, you need command word decoding, Peel framework application, and a solid time management matrix. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.